Welcome back to the Data for Good podcast. What an episode we have in store for you today. We are joined by Daniel Schley, who built his career in software engineering and development and then evolved and moved across into data and has led data operations and data engineering at companies across Berlin. Today, we're going to be talking about the importance of upskilling in data engineering, especially with the rise in the amount of data tools and the growing amount of data. We will be talking about SQL, cloud native data tools, how are we bridging the gap, and how are we embracing best practices from other areas of tech, including product and software development. Enjoy. Daniel, welcome. Thank you for joining us today. We've got a hot topic, very relevant. We're talking about upskilling data engineers. Why is it important and why are we talking about that today?
Yeah, thanks for having me. Why is it important? I think I just recently looked into how data systems in general, I would call it, evolved over time. And while there was a majority of data warehouses from the 1970s, in the last, I think, 10, 15 years, there was this explosion of data and also data tools and frameworks and everything. And with that, I think there was also a growing necessity of being able to work with these different tools, which not always support just SQL, but also like programming languages. Think about like Apache Kafka, Apache Spark and Kafka and the likes, right? Where you also use Java, Scala, and so on. And I think that all requires a bit more than what used to be there. And so therefore it's interesting to look into what else is it and where do you draw the line also between data engineering and what else do you need and who's building that, right? Yeah.
So coming from the DBA, the database administrator, into a more modern data engineer.
Yes, exactly. And also with the, let's say, move to the clouds, where most systems these days are built in cloud services, and where you glue together different cloud services, you have to build the infrastructure around it. You have to build up your storage and all those things. You either need a team that is doing that for you, and then you just have data engineers doing a small part. Or if you also would like to work in a, let's say, more cross-functional way, people that used to be only working with one piece maybe add another piece to their tool belt and also increase their knowledge and also their skill set.
Yeah, a big shift to the more cloud native databases. Do you think we've been a bit premature in the big shift, or is it been the right time to start migrating and evolving the data stack?
I think that depends completely on who you ask, right? So I'm a big fan of building solutions in general for that suit what you need. So I think, for example, we saw that with microservices when it became a hype, and big companies like Amazon or the likes, they started to build microservices. Everyone followed and started to build microservices. Did all of those people need microservices? I don't think so. And at one point, they realized they don't need it, but at that point it was already very expensive and they spent a lot of money in building this.
A lesson that's learned from software. You mentioned the microservices and what's been going on there. Is that now kind of the lessons that the data are learning from?
It was more like an example. I think it could be also used as a lesson in terms of aim for the right thing you need. And for example, what we are currently building is it's a huge leap from what was there before and what is happening in the future, but it suits the needs because there's from only structured data in the past, there is in the future structured, semi-structured, unstructured data, like everything, right? So there's a potential for using everything, and therefore the architecture fits what the need is. And then you also can, of course, scale inside that. Like, right? Do you already need like, or do you have terabytes in the beginning, or do you have gigabytes? Right? So there's differences. I think it makes sense to look into what do you need. But nonetheless, I would say there is some engineering practices that help you along that way anyway, coming with new technologies and new tools.
What do you think the most obvious one? What's the low hanging fruit for
And
software best practices that data can start embracing?
again, this I think also depends on where you're coming from. So like, what is the systems you are used to use, you were used to use, and what it is you're going to build. For me, for example, right now it's we used to work with, let's say, yeah, more or less classic data warehouse systems that were basically mostly supporting SQL. And I mean, SQL will be important for data, I'm sure, forever. At least so far, nothing better has been found, I think. But it was just recently when one of the engineers said, like, "Oh, this just feels, I don't know, in the old data warehouse, there was features that were built in, and now it seems like we have to build this from scratch." And this is a downside of modern cloud native data architectures, that some things are not built in per se, and you have to build up to the level you are used to as a data engineer, maybe working with a closed system data warehouse. And one funny thing though happened recently, and that's in an interview, I asked a candidate, how do you modularize SQL? And the answer was, I actually never thought about it. And then we talked about why it might make sense to modularize SQL and not have like big blobs of queries, but more like smaller chunks that are better maintainable, better readable. And the same candidate left the interview and said, like, I never thought about this, but actually you inspired me a lot to think about it, because now I will think about how I can modularize SQL better and how I can make it more maintainable. Coming to the low-hanging fruit. It doesn't matter if you talk about Java or Python or whatever code you're talking about. Also, SQL is code, and there's these famous quotes of 80% of your time you're reading code as opposed to writing code, right? So whatever you write, you should write it in a way that not only you, but most people are able to understand it. And if you write a monster SQL query, you might at one point know what it does. Everyone else will have to spend a lot of time to understand what it does. And the same goes for you, by the way, the same after some time, right? Months later, you come back and then you look at it and you're like, oh, what did I do here? So I think that's one low-hanging fruit, like looking into producing code that is easy to maintain, and having smaller pieces, as in modularity, definitely I think is a thing that is to aim for.
Are we an era where data engineers, comes back to upskilling data engineers, that things have always or are being done the way they've always been done, and now it's kind of that need for thinking outside the box and trying to work out how to best use all these new tools?
Yeah, so it's again, I think it's for example, what we are also doing right now is not to try to do too much at once, right? So you focus on something new and you add something to the tool belt. Coming back to this to the SQL versus not SQL only anymore world, right? So in our case, that's more Python now, which is, I mean, everyone knows, right? The number one data programming language, I would say, still these days. And you can start to use that slowly, right? So you start with strings that contain SQL, and then you start to work with these strings, and you start to learn slowly how the language also works. But I think the modularity aspect is even more interesting. It's like because we also recently looked into, okay, how can you do testing? What kind of testing do you need to do for data pipelines? And of course, quality is number one that comes to mind for data, right? You want to check the quality of the data because it's always bad. It's always bad or could be better, and you want to be sure. But it doesn't matter if you have SQL or if you have any kind of other code. It's kind of like retrieving or transforming data, right? So it does something to your data. So in turn, it basically changes the quality of the data to better or worse. And I just recently checked because I didn't know, but there is a thing that is called like SQL unit tests. So you can write unit tests to test your SQL. I don't think many people do that because I've not seen it.
It's the first I've heard of it as well.
Okay. Yeah. So yeah, I never had the impression many people use that, but you can do it. I'm not saying it's needed or you should, because also you can choose your let's say area of testing wisely, but you should do some testing. We all agree, I think, on that, right?
Yeah.
And what I'm trying to move the needle to right now is like not only testing the data, so like the result of your transformation, but also check the piece of code that is doing a transformation for whether it is doing the same thing again and again. So whether it is consistently delivering on what it should be doing. Of course, based also on facts like, okay, do you change that code often, right? You could say like if you don't change that code, that piece of SQL or whatever it is, if you don't change that and you know it works, why would you test it? That's what I hear often.
Broke, don't fix it.
Yeah, but there's rarely the case that you don't touch it again ever, right? And what's the chances that you are the one who's going to touch it the next time? I don't know. Maybe someone else is touching it, and maybe they don't know what you intended to do with it, and then they change it. It's another example from life. Like a data engineer recently told me, I got this piece of SQL. I'm supposed to retrieve some data, and it scares me because every time I run it, I receive different data. And I said, okay,
red flag.
That sounds tricky, depending on the case, right? Of course, if you're running some, I don't know, Kafka SQL on a stream, of course you get a different results, or it's more natural that you get a different result. But in this case, I think it was not intended to get different data. So I said, okay, that sounds dangerous. Yes. And so I think these two facts, right, like trying to make this code first more human readable or maintainable, and then on top maybe adding some more testing, is definitely helping you. But there's also since we talked about it earlier, like microservices, right, like this movement which basically led many people to follow. Maybe not everyone should have followed. It's also, there's a similarity in these cloud native data architectures where you basically also need, because of the distributed nature of those cloud native systems, right? You have like this service there, you have different frameworks that do different things. You have not only a relational database, but you also have like streaming data, and so you have more pieces in your architecture basically. And if you have more pieces, it becomes less controllable, unless you have more observability, which is another aspect that is needed for microservice. So if you go to microservices, you need more observability. And my claim is, if you go to cloud native data architectures, you also need more observability because you have more pieces, and the people will not be able to manually observe what is happening, right? Yeah. And then, of course, there's also all these principles also from software engineering, like automation, the DevOps/data ops, ML ops, right? Like ops, the whole X ops, I would call it, for short, to introduce that. I think that is also needed, and in parts like sometimes the new thing, because people were not used to work like that maybe before.
The intertwining of disciplines, and
Yeah.
one we've spoke about before is maybe the full stack data engineer.
Yeah, I actually Googled it after we talked about it, and of course we were not the first ones to claim that term, right?
No.
Someone already used it. I think it depends. Yeah, it's a bit more vague. So what does full stack data engineer mean? Is it more going towards this ops world? Is it more going towards like something else? I don't know, or more towards machine learning, whatever. I think it makes sense though, right? Like I'm in most aspects believing in cross-functional teams are better teams. So people learning from each other, helping each other, like instead of having really people with, let's say, more focused skills that don't know what else is happening around them. So yeah, I think that's a good thing. Like the full stack data engineer. Just happened recently also where we had a, let's say, an exchange and met on site, and there was some machine learning people showing their work and what the models are used for, and also how they monitor their machine learning models. And that was a very interesting part, because then one of the data engineers said, so like ML ops, and I said, yeah, that's what it is. And
Yeah.
it becomes really interesting then also to see these synergies that are possible between having an engineer and their mindset, look at what a machine learning person is doing, and see how they can help each other.
Yeah.
Right? Like there's things I could do for you, so you don't have to do this way, and you have an easier life, and you just know your machine learning model works. And I think that is what ML ops basically means, or ML engineering and ML ops then are trying to cover up.
Yeah.
But I think in general it makes sense to look above the very tight description of one's role, right? Like
Yeah.
I'm not only working
Extend your
with machine.
remit.
Yes, exactly. And I think this is what also helps with upskilling, and maybe not only for data engineers, but for all other roles in the data world.
I think across tech, I think with the tools that are available, people's remits are being extended,
Mhm.
and we're seeing a lot of merging of positions. And I think, like we're saying, upskilling, it'd be criminal not to get involved and be curious
Yeah,
with continuous learning and challenging
yeah,
the status quo.
yeah. And continuous learning is a good yeah, keyword. It's I found this is one of the most interesting skills, at least I realized in my career, to not think, oh, I already know everything there is to know in this area or in this aspect. So be open also for different perspectives, which is also kind of learning, I would say. And also, yeah, be open to say like, okay, we used to do this like for maybe even for a long time, right? As I mentioned, like data warehouses have been around for like 40 years, more or less. Of course, developed over time. There's more features, more functionality available. But yeah, also be open. Like, okay, what else could we do, or how else could we approach this? Is this the only way we can do this, or is there another way to do it? I think it's the first ingredient for this upskilling, right? Like to be open and extend your horizon. Like, okay, what else could be done here? Frankly, and fortunately enough, I have people on the team that are willing, right? Like they say, like, "Oh, it's interesting. Let's look into
Yeah.
this." Yeah. So yeah,
It's hard to find that curiosity. It's not something that is obvious from the start. It's something you have to coax out of someone, I guess. Did you find that?
yeah, and I mean, it's also funny enough a similarity also between software engineers, data engineers, and I mean, I worked most of my career with software engineers, but there was this pattern of people, especially in the early stage of their career, and I think I was like that myself. So you study computer science and then you enter the professional world and then you work on projects or products, however the company is structured.
Hmm.
Um, but then you're like, the requirements are always unclear. Uh, I don't know how often I heard that or said it even myself.
Yeah.
And when I heard it most recently in the last couple of years, I usually said, they always were, they always will be unclear,
Yeah.
more or less, right? So it's like it's one of the hardest pieces to figure out what it exactly means.
Mm.
And I see now also that this is also true for data engineering, right? So it's like finding out, okay, you gave me some description of what kind of data you expect here, but to tell you, reality looks a bit different. So how can we get together here? How can I give you what you want, and how can you accept what I have to offer? Um, so it's even a part that is not even technical, right? It's like more like interaction between human beings, talking about what is expected and how to find together.
Yeah.
Um, and that's a similarity, and it's funny enough also a topic we talk about a lot right now. Again, everyone open and being interested in also learning there. Um, because that's also what you have with more cross-functional working ways, right? You
Yeah.
have to learn each other's language, and then you can start to learn each other's skills also from. Yeah,
Would you say there might be caution with curiosity for being maybe too curious and focused on the solution rather than the problem? The curiosity of the problem, you could find different solutions. Are we focusing too much on the tooling and the methods? Could that be
I think.
holding us back?
um, I mean, that's maybe a completely different podcast episode,
Maybe.
right? Product-led thinking in data is also, I mean, um, yeah, I just recently mentioned it also, right? Like, don't fall in love with the solution, fall in love with the problem is, I think, also another famous quote from the product management world, you could say.
Yeah.
And it's exactly what you just phrased, right? It's a trap. You often tend to run to if you don't consciously stop yourself from doing it, unless you maybe made it a habit to not fall into that trap or walk into it. It's also often, I mean, I often used and am still using also this phrase, please don't bring me solutions, right? Bring me
Go
first
on.
bring me your problem first, because the solution you see might not be the best solution is available. And it's not necessarily that I know what is the best solution, right? But if you
Mhm.
come with the solution you have in mind, how am I supposed to give you a different one that might be available? So yeah, that's also, I mean, again, it's upskilling not for only for data engineers, I would say, then in maybe the whole working context, actually, just to
Yeah.
create value together, right? And the right one.
Data, like we meant, databases and data warehouse have been around for 40 years, but it sounds like the data space is only just starting to learn from product thinking, software development best practices. Could it be like an era of enlightenment for data and engineering in particular?
I mean, I do at least hope so. And I'm also right. Like I'm always challenging myself because I said most of my career was software engineering, so I'm often asking myself, "Hey, Daniel, are you maybe taking it too far here, expecting things that shouldn't be there in data
Mm.
engineering?" And for sure, data engineering is not software engineering, so there's differences.
Yeah.
But um, on the other hand, it's also, and I don't want to, yeah, ruin the mood, but even though software engineering is a bit ahead of things in certain aspects, many people still don't use the available methodologies and wisdom. So I think I shared this link with you, right? And about this video. So there's this, I think it's a conference talk from 2019 about the art of system design and the lost art of system design in software engineering. So like 5 years ago, there was people talking about why people are not doing conscious software design. And of course, you also need to do design for your data solutions, right? It's like you produce code, like I don't know, maybe Python code, and you use I don't know, certain pieces of code that you glue together, and it makes sense to just send at a whiteboard and draft it, right? Like talk about it with the other people that are working on it, and just figure out maybe first flaws before you started to code it. And so I would hope there is a bit of an enlightening, but not only for data engineering, but actually everywhere. So it seems like people also sometimes forget what was already achieved. But then there's also these things that come in waves, right? With everything, there's the we overdid it, I think, in software engineering with some principles. When I studied, there was all the UML, Unified Modeling Language, and you had to, I don't know, draft everything. And then at one point, everyone realized, oh, we were taking it maybe a bit too far. Then there was the opposite tendency to not do design at all, or claim to not do design at all. And I think somewhere in the middle, as often, is the sweet spot, right? You do some, you just do some design. And the same, I would say, to go back to data engineering and the upskilling topic, you do some of the things that are useful in software engineering, because you might find that they're useful in data engineering as well, right? So to give an example, testing is one big topic for me right now. It's we mentioned it before. I'm not the only one, so I always try to check my view on things there, and realize that there's many companies out there in the data ecosystems that basically say, no, modern cloud data pipeline, you have the following testing strategies at hand. And there is unit testing, end-to-end testing, integration testing, performance testing, all the testing strategies, which are also used in software engineering. And do you use all of them for everything? No. You use them particularly in places where you think it makes sense, but you of course need to understand first why it would make sense to use this testing strategy in this area.
It could be like Goldilocks, a Goldilocks story. You have to try the two extremes to find the kind of sweet spot.
Yes, and I hope that's not necessary, right? So that would be great to not have to overdo it, to realize, oh, we don't have to overdo it. Let's just do this where it's important, or where it's relevant, so to say. But of course, it's it's a valid statement that there could be more. I was actually I think the first time I looked into big data topics was like 2015 or something at a conference. At the time, I was just curious, working in software engineering, but curious about data engineering. And looking at what people presented and what they talked about, what their problems were, I was already like amazed. Wow, there's so much you guys could just take over from best practices from software engineering. Of course, it changed a lot, right? There's a lot more that was adopted over time, but still, I think there's even a lot more that could be used with a grain of salt.
Of course, always. I'm conscious of time, Daniel. I mean, we could unravel a lot of points. This could have been a much longer episode. But to kind of bring us home, what you mentioned testing, you're working on a lot at the moment. What else have you got coming up? What you're excited about in the next 12 months?
Yeah, testing, observability, I mentioned it, but observability in data is not a new or how should I say, unwatched topic. Same goes for testing. It's just like maybe to go back, get the loop back to the software engineering and or upskilling. It's sometimes more unfamiliar methodologies, which I think could be made more familiar. One is also it's really like about more like low-level coding principles, like dry and solids. So recently started with engineers also to look into some best practices in writing code. As I said, like you write code, but you more read code than you write code, and so making this code well structured makes a lot of sense. And so this is another thing I'm also looking into, or looking forward to look into.
Nice.
Yeah.
Awesome. And you, the team, how can people keep up with you and the work that you're doing?
So we're building right now a data lakehouse in the cloud.
Another episode.
Most probably, yes. And trying to become better, right? Like in what we are doing in all aspects, and learning from each other. That's actually also nice, right? I expected this from the beginning, not being traditionally coming from the data world. So there's a lot of things I can learn also, of course, from data engineers and analysts.
Learning a lot and adding a fresh perspective for them as well. Well, it's been an absolute pleasure, Daniel. I must say, time's absolutely flown. Thank you for joining us.
Thank you for having me.
And ciao for now.
Bye.